Labs, and I just want to do a live demonstration of my coordinates web tool, which you can see right here at pyroslabs.com/coordinates if you want to check it out yourself. And originally, I made this kind of inspired by my students because I teach math, and it's kind of like high school level math where you might have to learn about algebra. I actually had some students who also were hearing impaired and also visually impaired, and that kind of opened my mind to thinking about math in different ways. One of the ways that I was thinking about math was instead of graphing equations, like what you see right here, maybe we can listen to them as well. So here is the equation, y equals x right here. And the equation that I'm displaying is right there. I could change it, but let's just leave it as y equals x. And the whole point of this coordinates app is that you don't have to look at the graph. You don't have to visualize it. You can listen to it instead. Close your eyes, listen to it. Just getting that to play was a feat in web development, so I'm proud of that. In any case, this is a free open tool. I might use it for like 10 minutes in my own classroom with my students. But the fact is, it's just a nice toy. It's a web toy, an educational web toy where you can sonify, sonify, math equations. So instead of visualizing them, I want to sonify them. I want to make these equations and you can understand them through data. Now, we just listened to an equation with a slope of 1. Let's increase that slope to 2. Close your eyes and listen to this. Now, the way this works is there's a little bit of a delay. And then it started. And the reason why there was a delay was because, well, if you can see my graph, it's because the graph didn't even start until around negative 12 or so, because our graph was off the graph. I should say our curve, our line was off the graph. And so we only started to hear it, let's do it one more time, when we got to that point. And you can also hear how this bigger slope of 2 is represented by a faster speed up the piano. So I digress. I'm getting ahead of myself. The way this sonifying app works is you're just changing our visual coordinate plane into an auditory coordinate plane. The x-axis visually is the position left and right of different coordinates. And the y coordinate would be how far you are up and down in the visual coordinate plane. All we've done was we've translated the x coordinate in time. How much time is passing. And every 1 unit in the x direction is just 1 quick beat. And actually, if you bring it back down to the first equation we had, you can hear every beat. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, you know? And it started at like negative 23, going all the way to 0, all the way to positive 28, and you can see it listed in our x scale over here. And likewise, I had it so that our y scale started at negative 23 all the way to positive 28. And the way we're looking at it right now, time starts at negative 23, all the way up to positive 28. And the y value, which is just our pitch now, it's not distance up and down, it's our pitch. Well, that starts at negative 23 all the way down here on the piano. Right? So if you don't have a piano in front of you, you can just use this app. And it goes all the way up to 0 over here. That's middle C for all you musicians. All the way to the highest value of positive 28, right up there. And so that's our coordinate system. To make it easy, maybe let's start over. Let's change our coordinate system so that time starts at 0. Negative time is kind of hard to think about in the beginning. So we'll just start from 0. And let's make our piano keys start from 0 to 51 as well, just to look at it that way. And our linear equation looks the same, of course, because I mean it starts at 0, 0, goes all the way to 51, 51, and if I play it, it's the same kind of pattern. Let me stop that, because 0, 0 means at 0 seconds you play the 0 key right there, and you know at 51 seconds you play the 51st key up here. But now if we increase that slope again, I'm going to make it y equals 3x, and I play this. Well, as you can see, what you're going to hear is a auditory pattern that's increasing faster. So let's play it. And boom, it's done. Our auditory graph was already off the piano, or off the page in the case of our visual graph here. So yeah, this is our demonstration of how it's working. All we're doing is translating these visual graphs and these equations into an auditory graph or a sonification. And let's look at the influence of our y-intercept. So if I increase this to 10, if my equation is now y equals 3x plus 10, what is that going to sound like? What do you think? And we click this and we find out. Let's try that again. It started out at a higher pitch. So basically, when x was 0, 0 seconds from the start, we started out at note 10, which I think is like this one. I didn't really see. Let's try that again. Oh, yeah, okay. It was right here, this D note, which looks like it's D2 for those musicians who are looking at it. If you hover over a piano key, it'll give you the musical name of it, you know? So you can analyze linear equations with this app, and you can also analyze a whole bunch more types of math equations. Click on the function type. If you want more help, by the way, to understand how to use this, you just click on something and it gives you like some explanation of what's going on. This option changes the type of mathematical function or equation that's displayed, and that's going to be made audible. There's a little video explaining how that works. But I'm just right here. So these are all the math equations that I programmed into here. It's not as good as Desmos.com. All you math teachers and math people know what Desmos is, the online graphing calculator. I think it's fantastic, but that's not what this is. Instead of putting in any equation you want, you actually have to choose the equation that you're going to analyze. So let's analyze a quadratic equation, which is a polynomial. So it's in alphabetical order. We'll go down to the polynomials: exponential, linear, logarithmic, polynomial. And let's do it in factored form. How about that? And I'm only doing that because then I can decide the zeros or the roots of the equation. So for example, if I want my equation to hit 0 at 5 seconds, I can, put one of my factors as x minus 5. And then I want it to hit 0 at like 35 seconds. So we'll put minus 35 over here like that. So there we go. That's what it is. And what happens if we just make that coefficient 1 in the beginning? Oh, there we go. That's a bit much. Let's change that. Instead of 1, we'll change it to like 1/10 of that. There we go. Let's listen to that and just hear what that sounds like. What would this graph sound like on the piano? And then it went off the page or went off our piano. It comes back up. And I think that's cool. I really think that's cool. Just because I'm a big nerd like that. Let's put a negative coefficient up front and see how that does things as well, how that changes things. Also, you might notice that in this web app, the way I've programmed it so far, there's a little problem with the notes in the beginning because my computer takes some memory to load in all the piano keys, and it kind of jumbles the beginning notes sometimes. That's okay. You just have to play it again, and then it'll play more smoothly. Let's try this. is what a quadratic equation sounds like when it has a negative coefficient. Let's hear that one more time. You heard that, right? You heard the vertex. We were rising up our piano, rising in Y values, and then we hung out at this top area and then went back down. A vertex is wherever you change direction in the on the piano, or I guess in the Y direction with our quadratic equations. So let's look at one more function type, and then we can demonstrate some other features here. Let's try the sigmoid function. So the way this is going to work is sigmoid functions are S-shaped functions. So here's our S, I guess. They're cool because they're used to model lots of things like populations. So let's say this is the population of something, and I'm just trying to modify our parameters here of this equation so that it kind of stretches across more of the piano, more of our Y coordinates. We would say in math, it goes across our entire range. And our range are piano keys, you know? Oh yeah, you can click on the piano keys without being attached to an equation. But yeah, so I've got this logistic equation here. Y equals 45 all over a denominator of 1 plus e to the negative 0.2. Well, let's say 1 plus e to an exponent, and that exponent is negative 0.2 times the quantity x minus 20. Whew. And what happens if we play that? It might bunch up a little bit in the beginning. If it does, I'll just stop and replay it. There you go. You heard that? It was increasing, not linearly, not smoothly, but then it kind of just hung out at the same note on top. It was flat. It was plateauing. There was an asymptote, as they say, as we approach a particular value here. Like, I guess it was this one, this D note, which is like 45 or something in this set of coordinates and coordinate plane. So that's what that looks like. Maybe I'll show you one final function. The statistical functions are kind of neat. So you can also just display random numbers. So the equation could literally just be y equals a random distribution of numbers. And you just have to set your maximum and your minimum values. So I'll say that our random numbers can go from like, I don't know, 14 to 35. And if you play this function, let's hear what that's going to sound like. And go. That's random. Well, as random as JavaScript can make it. It's not truly random if you know a little bit about algorithms and JavaScript, but it's sort of random and it's cool. Yeah, so you can do a whole bunch of sonifications of different functions. Not only that, but you can choose what musical scale you're going to use. So musicians will know what we're talking about for sure, but I think a lot of people already know that there are major keys or major scales and minor scales. Well, here is C major. It's the same thing we started with. A little bit of lag, that's here, but let's try C minor and hear what that might sound like. Musicians will know this, but every minor scale is really a major scale if you think about it differently. They're all relative. So the C minor scale could be major if you're thinking about it in the right way. It really depends on what your root is or what note we're starting with. And because this is a linear equation that goes infinitely, we aren't really starting anywhere. So that's an interesting thing to think about as musicians. Um, you don't need to have diatonic scales or 7-note scales. You could have a chromatic scale. You could do all the notes on the piano. This is still Y equals X. Zero key. And, oh, I forgot the X scale and Y scales had reset. So it's not 0, but it's like at negative 39 seconds, we played the negative 39 key. Here, let's change that one more time. We'll go from 0 to 87, 0 to 87. Try that once more. I was just saying that if you listen to this delay, we get the 0 key. And I shouldn't say seconds. I should say beats because we're going really fast here, At 12 beats, we were going to play the 12th key, which is somewhere up here. 36 At the 36th beat, we were going to play the 36th key, and so on and so forth, all the way to like the 87th beat was the 87th key, all the way up here. And so that's the chromatic scale. It's using every note on our Western view of music. We can still do pentatonic scales. Let's try all the black keys, and we'll keep our positive X and Y scales too. Let's play that. Very Chinese sounding, if I do say so myself as a Chinese American person. So it's just another way of sonifying an equation. You're still representing the pattern similarly. At 0 beats, you're playing the 0 key, and 0 is now this one right here. And then at 5 beats, you're playing the 5th key. So 0, 1, 2, 3, 4, 5, right? And so on and so forth, all the way up to the 35th beat and 35th key up here. So this musical scale thing is really neat. I like the Hirajoshi scale personally. That's like a pentatonic scale, often found in old Japanese folk songs. So you can play that and hear it. It reminds me of like old video games on the Commodore 64, like ninja video games. Very, very old school and basic because it's just like bump, 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 bump. There's no complicated rhythm or anything. So that's neat. You can change your scale. I've already shown you this. So let's just randomly choose some stuff here. Your X scale doesn't have to be preset. I have preset some scales for every musical scale. I've selected preset X and Y scales, and that is to make every beat match up perfectly with one of the notes on the piano. If you have, for example, the C major scale consisting of, 52 keys, well, I wanted to make sure that there were exactly 52 beats in the X direction to correspond with 52 potential keys on the piano. But you don't have to make it that pretty. I could just set my own maximum and minimum. Let's say I want to look at this hyperbola specifically from like negative 100 to well, that's way too big. Well, whatever, it's fine. Negative 100 to positive 150, just because we're demonstrating it. And likewise for the Y, I don't want to stick with these nice preset ones. I want to look at it from, in this case, let's try like 5 from, oops, that's the wrong one. Oh no, I put it in the right spot. The minimum is 5 and the maximum is, I guess that's, I don't know, that should be all right. 100? Yeah, let's do that. So now we have changed our domain and our range, our maximums and minimums for the X and Y coordinates. Likewise, we've changed that domain and range for our time and piano keys. So we've just mapped everything a little differently. Now if you set your own custom X and Y scales, you have to know that no longer are these beats going to correspond to anything special. Like in X, we're just arbitrarily choosing to have a beat every, couple milliseconds or so. I believe I programmed it to divide all of these things to like 50 beats no matter what. So let's just play it and hear what this looks like. It's a hyperbola with this particular set of domain and range and major key playing now. Let's try that again. It had that little hiccup in the beginning. Nice. It was almost like an absolute value equation, but a little curvy on the bottom. I think that if you zoomed in, you would notice that curve a little more. So maybe we could try that next and just look at it one more time. I hope that this demonstrates some of the complexities that you can deal with in an app like this. If you were a math teacher or a music teacher, in your classroom messing with it, I would hope that you could talk about different mathematical or musical concepts and kind of integrate it into your class, especially if you have learners who need another connection to the math. Whether you're visually impaired or not, you might just have musicians in there or people who like thinking about math in different ways. All right, let's listen to this hyperbola. This top half of a hyperbola, I should be more specific here, starting now. Let's try that again. That is what the top half of our hyperbola sounds like. Very curvy, but it gets the idea across that you're going up and down. It approaches a linear equation away from the vertex. So that's interesting. And as you listen to more of these sonifications, you get to recognize these auditory signatures or oral signatures. Kind of like each of these equations has visual signatures, like a hyperbola and a vertex. Well, if you listen to it, you can kind of hear that asymptote as well, how it approaches a linear equation. You can definitely hear the vertex too. It's just really neat to think about these auditory and visual analogs. All right, let's clear this out. I'm going to click the main button and a preset one already in the website. If we use the standard rhythm that we've always been using so far, the rhythm or the amount of beats, I guess, that you play or the pace at which you play a note is going to be constant. Just boom, 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 right? That's the way I've programmed it. And let's hear that for this cubic equation right here. Oops. Well, like I said, if it doesn't hiccup, it would be even. But let's do that again. There, you can hear it. It's supposed to be relatively steady. I've made it where I programmed it where you can choose a free rhythm as well. So instead of playing exactly on the beat, like dun 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 dun, you can instead play whenever you cross one of the piano keys. Let's hear what this sounds like. Never mind. I think there's a hiccup there. Like I can see it's loading. So clearly I need to still improve my web development here. So you're coming along for the ride. Let's try that again. I think it's actually loading YouTube help videos in the back. So I'll have to deal with that later. Let's play that again. So it's a little slow. And in doing these live streams, I'm realizing, okay, this is what I got to debug. I need to make sure that these videos in the background, these help things, that they don't, like help windows have videos like that in the beginning. I'll note that down. But the whole idea was that it played all the notes on the piano as needed. You did not have to wait for the beat. If you waited for the beat, it would only play it at specific times. And if you missed some piano keys in between, oh well. Oh, all right. So clearly I'm crashing my own webpage. Let's wait. Let's continue with that. We can move on. So that's the rhythm. I also have an option to control the timbre of the sonification. So if you don't want to hear a quick piano key, maybe you want to hear a slow. Let's hear what that sounds like. Oh, never mind. Let's see if I can reload this. Oh, wow. It just loaded all of the guitar keys at one time. These are the live stream bugs that I gotta get used to. All right, let's see if I can straight timbre, and you can always do Safari. I forgot to mention this does not really work on Safari, unfortunately, so I still got to debug that. But yeah, the guitar. Oh, it's not working right now. So you'll have to load that up yourself, and maybe I can live stream that another day. But I am sure that it does work. It just I'm not sure why that's not working. But yeah, I can click on things like that. Like it sounds cool, I think, when I listen to one of the cyclic functions, like say, I don't know, a cosine function. I want to hear if this works. There we go. It's like playing one of those old-timey video games with a really bare acoustic soundtrack. So, yeah, I think that's cool. And we can change that rhythm up too if you wanted. I wonder what that'll sound like. It's like a harp or a harpsichord or something. So I just got that guitar tambourine recently, so I'm very proud of that. It's very mystical sounding. The sine wave with the guitars is so cool. I feel like besides teaching math, you can maybe inspire your musical sensibilities or jog your musical creativity by listening to what these curves sound like as sonifications. So that's another exercise I would like teachers to give their students if they got time. And then finally, I've got harmony here. So if you want to hear like minor third harmonies, you can play that as well. It just sounds really ugly. But let's reduce the beat there so that we don't have so many things playing at once. Just goes to show you don't want to have the same harmonic interval on all your notes because then it just sounds dissonant. All right, so that's that. I showed you how you can mess with all of these options to sonify or listen to mathematical equations on musical instruments, which is awesome. You can even save your graph as a PNG by clicking that button. It works on all the browsers except IE, this whole website doesn't work at all. On Edge, you have to like right click on it and save. You can always do that on any browser, but on Edge, you're forced to, unfortunately. You can even tweet this graph out, this specific graph, which is cool. Because let's say you want to share this particular sine equation with the guitar, with this rhythm, well, when you share this on Twitter and they click on that link, they'll go straight to what you're seeing right now, and they can just click the play button and hear the exact same thing. As ugly as turn off that harmony. That's a case where harmony sucks, so I'm going to turn that off. And so, yeah, I think I've shown you pretty much everything I want to show you. It's been more than a half an hour. And my rambling is done. I want you to go and explore this free Coordinates web app in your math class, music class, homeschooling, whatever. And please, please give me feedback. If you click on this give feedback where all the bugs are, I will know about Safari. And maybe nobody uses Safari. That's good to know too. I already know I have to fix like the YouTube video loading, but what else fix? What else would I or should I add? Do you want to hear flutes? Do you want to hear singing? Do you want to get the Kosh function and catenaries? I don't know. It would be great to hear from you. If you create music from this, inspired from this, I would love to hear about that as well. Just get in contact with me. Get in contact with me by clicking on Pios Labs, or you can find my info at my website down there. And that's it. Thanks for following my stream and hope to hear from you soon. Signing off. Bye.